Here's the review for our spring final exam over rational expressions, equations, and graphs. This will be your Chapter 8 notes, so if you need to get those out to look anything up, that's where you need to look, Chapter 8. So first of all, we have, I moved that too far. We have 70 divided by 21x plus 7. Well, 70 is a single term, so it can't be factored. 21x plus 7, those can both be divisible by 7. So if I take out a 7, I have 3x plus 1 left. Remember that 7 is a GCF, and we're factoring, so we factor it out. Now if I look, my 70 and my 7 can both be divided by 7. When I divide 70 by 7, I get 10. When I divide 7 by 7, I get 1. So when I come across here, I get 10 divided by 3x plus 1. And then remember, anytime you have a fraction, you have to list your excluded values. Excluded values come from the denominator only, and they come when I set that denominator not equal to 0. And so if I solve that, I get that x cannot equal negative 1/3. That's my final answer. Nothing else can divide. Remember, the 3x and the plus 1 are superglued, so even if 10 and 3 or 10 and 1 had some factors in common, I couldn't divide them out because that plus sign or minus signs acts as superglue, so I can only cancel the entire factor. Next I have b minus 4 divided by 9b minus 36, and I can already tell that 9b minus 36, I have a GCF of 9, so when I factor that out, I have a b minus 4. Now I forgot to do it on this one, but I need to do these excluded values before I cancel anything. So in the denominator I have a 9. That doesn't have a variable, so it doesn't have an excluded value. I have a b minus 4. That does have a variable, so I have an excluded value. Set it not equal to 0, so b cannot equal 4. Now, in this case, the b minus 4s are the exact same factor, so they can cancel. Now, my denominator I still have a 9 in. My numerator I completely canceled the factor that was there, but even if I canceled the factor that was there, I can always factor a 1 out of it, so there's always going to be a 1 left no matter what. So my final answer is 1/9. This next one's a little more involved. 3x squared divided by, then it's 3x squared plus 27. I can tell that has a 3x in common. So 3x squared divided by 3x is just going to be x, and 27 divided by 3x will be 9. My next one, I have x squared plus x minus 72. So I need to factor it using the AC method. I believe factoring is in Chapter 4. If you can't remember how to factor, you can look this up, but you do a, which is the first number, times c, which is negative 72, and then you would make a list of factors of 72 and figure out which factors of 72 add to give you 1. I already know this factors as 8x plus 9 and x minus 8. And then I have 3x squared. Okay, now the first thing I need to do is my excluded values. So from the 3x, this is multiplication, so I would set 3x does not equal 0. Well, 0 divided by anything is always going to be 0. From this one, I would subtract 9, so x does not equal negative 9. Okay, and on this one, it would be about the same thing here, except this would be squared, so after I divided by 3, I would be taking the square root of 0, which is 0. So I'm just going to leave that one, and this one does not equal 0 as well, so I don't need to write it again. Okay, now we see what cancels. The 3x squareds, if I have 1 in the numerator and 1 in the denominator, they cancel. That 3x doesn't have anything to cancel with. X minus 9s cancel, and the x minus 8 doesn't have anything. So it's x minus 8 divided by 3x, and that's my final answer. Remember, when you multiply, remember on all of these, the first step is always to factor. You must always factor first. Okay, my next guy has a negative sign in front of it, so I'm going to factor that out over here to the side. Remember, you never want your leading term to be negative when you factor. Okay, that's better. So now I have A, which is 1, times C, which is 27. So I need factors of 27. So 1 and 27, 3 and 9. But they need to add to give me negative 12. Okay, well, it's not going to happen if they're positive. So it's going to have to be negative 3 and negative 9. So my first step again is to factor. And my second step is to list my excluded values. 5k squared minus 45. There's two terms, so I need to look for a GCF. 5k, so then it's k minus 9. Okay. After you've factored, then you list your excluded values. And remember, they come from the denominator only. You set all the pieces in the denominator not equal to 0 and solve. So you would add 3, you would divide by 5, and you would add 9, giving you these guys. Then after you have factored and listed your excluded values, you cancel. So the k minus 3's cancel, k minus 9's cancel. Okay, this 5 and this 5 do not cancel because this 5 is superglued to a k, and to a k minus 5 is the term, so I could only cancel another k minus 5 with this. These are multiplied, so it's a different mathematical operation, meaning I can't cancel it. So in the numerator, and then after you've canceled, you multiply straight across. So straight across the numerator. Don't forget this negative over here. So it's negative k minus 5 divided by 5k. And I can't cancel anything else, so that's my final answer. Okay, 5. I have x minus 3, two terms, look for a GCF, it doesn't have one. 4x minus 36, two terms, look for a GCF, it does have one. Okay, now this one is a division problem. So it has the same first step, which is to factor, which I already did. Now the next step is also to list the excluded values. Okay, so x cannot equal from here, x cannot equal 9. And then same thing, x cannot equal 9 again, so I don't need to write it again. So I factored, I listed my excluded values once. Now I'm going to keep it, change it, flip it. So the first fraction stays exactly the same. Sorry, I messed up on that. Then the division sign changes to multiplication, and the second fraction you find its inverse, or flip it over. So now I have factored first, list the excluded values, keep it, change it, flip it, and now it's become a multiplication problem. So now is when I'm allowed to cancel. And, before you cancel, you need to look at the second denominator and see if there are any new excluded values. If there are, you need to list them. There are not in this problem because I don't have any variables in my denominator, so I can cancel and then write my final answer. Okay, 6. 1 divided by m plus 10. m plus 10 has two terms, so I need to look for a GCF. It doesn't have one. Next I have 8m minus 24. That's going to have a GCF of 8. So m minus, 3? And then in my denominator I have 18m minus 54. That has a GCF of 18. Okay, so remember, if it's two terms, you just look for a GCF. It's when it's three terms, like this guy up here, that you need to factor by the AC method. Okay, so now now that I've factored, look for excluded values. M cannot equal negative 10. 18 does not have a variable, so I don't need to use that. Oops, I messed up here. Sorry. When I take the 18 out, that's just going to be 3. Here, m cannot equal 3. And those are all my excluded values. Okay, so now I keep it, change it, flip it, okay, list any new excluded values, and those will only come from this denominator because it's the only thing that moved into the denominator. M minus 3, I already have an m cannot equal 3, so I don't need to add any more. Okay, now cancel, those cancel. 18 and 8 can both be divided by 2, and that would give me 9 and 4. and I can't cancel anything else, so I have 9 divided by, we want to move the 4 out front, and n plus 10 here. That is all. Okay, now on to 7, where we are adding. So this is a little bit different. Again, the first step is to factor. So I have 4 divided by n plus 5. I don't have anything to factor there. And 3 divided by n plus 6. Okay, so now what I need to do is determine what the common denominator is. Well, this has a denominator of n plus 5, and this has a denominator of n plus 6. So that's going to be my common denominator. And now what I need to do is, remember, you can't add until your denominators are the same. So I need to get my denominators the same. And how I do that is by multiplying each fraction by what it's missing from the common denominator. So this fraction has an n plus 5. It needs, let me do this in another color, it needs an n plus 6. And if I multiply on the bottom by n plus 6, I must multiply in the numerator by n plus 6. Now I have n plus 6 over here. I need n plus 5. And again, whatever you do to the denominator, you must also do to the numerator. So now this is going to require some distributing. So I will have 4n plus 24 divided by n plus 6, n plus 5. And then this will also require some distributing. 3n squared plus 15n. And now my denominators are the same. So once your denominators are the same, you can combine like terms in the numerator, but remember you keep the denominators the same, the denominator, because now I'm going to have a single fraction. So my like terms, I have 3n squared, that's my largest exponent, so that goes first. 4n plus 15n is 19n, and then 24. Okay, now on this I need to check and see if I can, well, first let's write my excluded values. My excluded values are n cannot equal negative 6 and n cannot equal negative 5 from my denominators. Don't forget that. Okay, and now I need to check and see if that will factor. So 3 times 24 for my AC method is 72. I need to see if I can get a factor of 72 that would add to give me 19. So 1 and 72, nope. 2 and 36, nope. 3 and 24, no. 4 and 18, no. 6 and 12, nope, that gives me 18, not 19. So since I don't have a factor, since I don't have, a set of factors of 72 that adds to give me 19, that tells me that this trinomial does not factor, so that's how I know I'm at my end. Now if it did factor, I would need to factor and then see if anything canceled. Okay, on to 8. 5 divided by 2a. Remember, you need to do any factoring, especially in the denominator, if there is any to do. That doesn't have any. A plus 6 divided by, okay, this next denominator is 4a minus 6, so that does have a factor of 2, and that would give me, nope, 4 divided by 2 is definitely not just a. 4 divided by 2 would give me 2a, and 6 divided by 2 would give me 3. Okay. Now my common denominator, I have a 2a from here. Then here I have another 2. Well, I have a 2 already, so I don't need to use that. And then I have a 2a minus 3. So my common denominator is 2 times a times 2 minus 3. So this first fraction, I'm missing a 2a minus 3. And remember, whatever you multiply in the denominator, you have to multiply in the numerator. Now this fraction, all I'm missing is an a. Then in the numerator, you need to distribute or FOIL. So I'm going to have 10a minus 15 divided by my common denominator, which is 2a and 2a minus 3. And this one, I have to distribute. So I have a squared plus 6a divided by 2a times 2a minus 3. Okay, Now I need to list my excluded values. So from 2a, that's multiplication, so I know a cannot equal 0, because 0 divided by 2 would be 0. And in this one, you would add 3 over and then divide by 2, so a cannot equal 3 halves. Sorry, I said 3, so I wrote it. A cannot equal 3 halves. Now that I have like denominators, I'm going to keep my denominator and add my numerators. So again, look for your highest power of an exponent, a squared. 6 plus 10 is 16a minus 15. Okay, so again I have 3 terms, so I need to check and see if that factors. So a, or this first number, 1, times c, or this last number, is negative 15. So factors of negative 15 would be 1 and negative 15, or negative 1 and 15, 3 and negative 5, or negative 3 and 5. Do any of those add or combine to give me 16? No, they don't. So that one doesn't need to factor either, and it is done. Okay, 9. 9 is subtraction, and I can't remember if Mrs. Miller and I do this a little bit differently. So if I do this a little bit differently than she does, you might ask her for a reminder. So first thing, you write it down, and then obviously you need to factor. These are all single terms, so they don't factor. This is 2 terms, so I look for a GCF. It doesn't have one. This is what I think I do a little bit differently than maybe some other people. I immediately change this to an addition problem and distribute this negative sign to any terms in the second numerator, because having this as subtraction sign makes me sometimes mess up. So if I immediately change it to addition and distribute the negative to any terms in the second numerator, then it helps me not mess up. So now again I have to get a common denominator. Now this common denominator is a little bit different. Okay, so I have this 3x minus 4, but remember that subtraction sign superglues that all together, so that makes that only all one term. So this 3 is actually going to be a separate term from that. So when I multiply, this one is going to have to be multiplied by 3 over 3, and this one by 3x minus 4 divided by 3. Or minus 3x minus 4, sorry. Didn't finish my thought. Then we multiply in the numerator only, so I'm going to have 18 divided by 3 times 3x minus 4. And then I'm going to make this addition now, and I'm going to distribute a negative 5 when I distribute. So negative 5 times 3x is negative 15x, and negative 5 times negative 4 is going to be positive 20, divided by 3 times 3x minus 4. Okay, now before you go on any further, you need to list excluded values. The 3 does not have a variable, so it doesn't have an excluded value. But 3x minus 4 does, so I would add 4 to the other side and then divide by 3, so x cannot equal 4/3. Now I need to combine like terms, keeping my denominator the same. So I've got negative 15 plus 38. Let's see if that factors. I can't think of anything that goes into negative 15 and 38. If you can, factor it out at the beginning. Yeah. Or if you don't want to leave that leading term negative, you might make it 15x minus 38 divided by 3 times 3x minus 4. That's probably better, to not have that leading term negative. On 10, I have 5r, so that's a single term, it doesn't need to be factored, divided by 4r to the third, that's a single term, it doesn't need to be factored, minus r minus 3, look for a GCF, I don't see one, and r minus 5, look for a GCF, I don't see one. And again, I am going to immediately change this to addition and distribute that negative to all the terms in the second numerator. So see, I changed both of those signs. Now looking for my common denominator, I have 4r to the third and I have r minus 5. So my first fraction is going to get multiplied by r minus 5, numerator and denominator. And my second fraction is going to get multiplied by 4r to the third, numerator and denominator. Okay. So I'm going to have 5r, I should skip a line, 5r squared minus 5r divided by 4r cubed and r minus 5. And, okay, so this is going to be negative 4r to the fourth plus 12r to the third divided by my 4r cubed r minus 5. It's a terrible looking 5. Okay, now for my excluded values, on this one, if I set it not equal to 0, I would divide by 4 and then take the cube root of 0, so it would still be r does not equal 0. And on this one I would add 5, so r does not equal 5. So my excluded values. Okay. Now combining like terms. Okay, I have negative 4r to the fourth plus 12r to the third plus 5r squared minus 5r. Okay, there weren't any like terms to combine, so I just needed to put them in standard form. And let's see if this can factor. If I take out something that these two have in common, that would be a negative 4, so I'd be left, or a negative 4r to the third, so I'd be left with r plus 3. If I took out something these two had in common, it would just be 5r, so I'd be left with r minus 1. Well, what I'd be left with here and what I'd be left with here don't match, so those don't factor. That doesn't factor, so that is my final answer. Okay, 11. Solving an equation. Okay, so first step, again, is to factor. And remember, if you don't remember how to factor, look back in your Chapter 4 notes. We also did it, I think, maybe before Chapter 5 in Section 5.3. So AC method, 1 times 20, so I need factors of 20. That multiply to give me negative 9. Well, that's going to be r minus 4 and r minus 5. Then I have a minus sign, r plus 1 divided by, okay, that same thing, so r minus 4 and r minus 5. And that equals 1 divided by r minus 5. Okay. Again, I don't like subtraction, so I immediately change it to addition and change the signs on my numerator that follows it. Now I need a common denominator. Okay, so my common denominator is r minus 4, r minus 5, and then I have another r minus 4, another r minus 5, another, okay, so nothing new. Now, on these ones, instead of like addition where we multiplied it top and bottom and we kept the denominator, these ones are where you just multiply each fraction by your denominator and then cancel your denominator. So the ones where there's an equal sign, only the ones where there's an equal sign, we want to make our denominator disappear. And the reason why is because that's going to be easier to solve than keeping a fraction. Okay, so now I see that the r minus 4 here cancels, the r minus 5 here cancels. In my second fraction, r minus 4 and r minus 5 cancel, and after my equal sign, only the r minus 5's cancel. Okay, so in this first fraction, everything's gone but an 8. In this second fraction, my denominator's gone, and I'm left with minus r and minus 1. Now in this fraction over here, only the r minus 5's canceled, so I'm left with r minus 4. But now, this is an algebra 1 problem. So we have minus r, 8 minus 1 is going to be 7, equals r minus 4. And then we get our r's to one side and get our numbers to the other. So 11 equals 2r, and then we divide both sides by 2. So we have 11 halves equals r. Oh, and I missed something. Clear back up here before I canceled. I should have done my excluded values. Sorry about that. Try to remember to on the next one. Okay, so my final answer is r equals 11/2. Remember, you have to double check that that's not one of your excluded values. Okay, 12. Again, factoring as I'm writing down. So I have 6 times n minus 4. Oh no, I don't need to factor on the numerator, sorry. Don't factor on the numerator because I need to use that when I have like terms in a minute. So I need to factor in the denominator only. So I have 6n minus 24, and the denominator I have n squared minus 5n, so I'm going to factor out an n minus 5. Okay, now my equal sign is towards the front. 1 divided by n minus 5 plus 6 divided by n times n minus 5 again. Okay, so my common denominator is going to be n and n minus 5. So once again, well, let me list my excluded values before I do anything else so I don't forget them again. N cannot equal 0 and n cannot equal 5. So remember when you get your answers to check against those. So common denominators, we have n and n minus 5. Remember, when there's an equal sign and an equal sign only, you multiply the entire fraction to cancel the denominators, if you can. Those both cancel. Only the n minus, and those both cancel. Okay, so from this first fraction, I still have 6n minus 24. From this fraction, I have 1 times n, so that's going to be n, and from this fraction, I have a 6. So if I subtract my n, I've got, and move my 24 over, I have 5n equals 30, and divide by 5, so I end up with n equals 6. Now double check that that's not one of your excluded values, and call it good. Okay, on to graphing. These graphing ones are, I believe, in your 8.2 and 8.3 notes, so you can look at those if you can't remember how to do this stuff. So 13, I need to graph f of x equals negative 4 divided by x. Okay, so as I graph this, this is the one where I have a black hole. And remember, the black hole, I'm just going to sketch this. It's not going to be the most amazing graph ever. Remember, the black hole occurs the opposite of what's in the denominator, comma, whatever's out here. So for example, if I had 1 divided by x plus 2 minus 7, then my black hole would be at the opposite of this, so negative 2, comma, whatever that says, negative 7. So if I drew it, I would go right 2 and down 7, and then I would make my asymptotes shoot out from there. And then that's where I would use my transformations to graph. This graph, though, doesn't have anything here, so my black hole is going to be at 0, and it doesn't have anything here, so my black hole will be at 0, 0, and I will have a my asymptotes will shoot out from there. So you draw your asymptotes in, remember, as dashed lines. So I'll have a vertical asymptote. Vertical asymptotes always start with x equals, it's x equals 0. And my horizontal asymptote will be at y equals, it's y equals 0. These always use these coordinate points, or this coordinate point, so if you have 0 here, that means your vertical asymptote is 0, and 0 in the y value means your horizontal asymptote is 0. Okay, so I found my asymptotes. Now I need to find my x-intercepts. So to find x-intercepts, remember that's always going to be a number, comma 0, because it needs to be along this x-axis. So if the y value is always going to be 0, what I can do is take this and make the y value 0. So to solve this, I would multiply both sides by x. Well, 0 times x is 0, and I get 0 equals negative 4, because those cancel. Well, that doesn't happen, so I would say that there are no x-intercepts, and that's probably true since I have an asymptote on my x-axis. Okay, next thing I need to look for is domain. Well, your domain is going to be all real numbers except any holes or vertical asymptotes, because remember domain uses x, so that makes sense that it would use x. So all real numbers except x equals 0, so whatever that says we bring down here. And the range is all real numbers except y equals 0. Yeah, I didn't need this. Okay, so range uses y. Okay, now my pattern for growing on this kind of graph is to go right 1/2 up 2, right 1 up, well, I can do it right here. No, right here. No. And right 2 up 1/2. Okay, so that's my normal pattern for growing. It doesn't say to list the transformations, but I'm going to. This negative gives me a reflection, and any number up here gives me a stretch or a compression. Remember, it's a stretch if it's bigger than 1, and it's a compression if it's between 0 and 1/2. So this is a 4, that's definitely bigger than 1, so it's going to be a stretch. So what a reflection does to my points is it takes all of these arrows that were pointing up and they now point down. And what a stretch does is I have to take all of my y values and multiply them by 4. So now I didn't make that quite long enough. I'm going to go right 1/2 and down 2 times 4, so down 8. I'm going to go right 1 and down 4, and right 2 and down 2. So here's this branch. Okay. Now remember, these branches are normally top right and bottom left. So these points go right and up. Normally these points go left and down, but a reflection will also change. These ones will now go up, and they will also have the stretch, so they are going to go up 8, 4, and 2. Okay, so over 1/2 and up 8, over 1 and up 4, over 2 and up 2. Oops, that's terrible. Okay, now remember, you can get close to your asymptotes, but do not touch or cross them. Okay, 14. F of x equals -4 divided by x plus 2. Okay, so this is going to look similar. A couple things are going to change though. My black hole, instead of being at 0, 0, is going to be at 0, 2. 0 still comes from the denominator. You do remember the opposite of what it says, and then your y value comes from over here, so 0, 2. My vertical asymptote is x equals the x value, so still 0. Horizontal asymptote, y equals the y value, so now that's going to be 2. My x-intercepts, maybe I'll have one this time. To get the x-intercepts, remember it's going to be some number and then 0, so put 0 in for your y. I'm going to move that negative up with the 4 so I don't mess myself up. Plus 2, sorry. Okay, so subtract 2. -2 equals -4 divided by x. Multiply both sides by x. That cancels. -2x equals -4. So when I divide both sides, I would get x equals 2. So my my x-intercept, is going to be at 2, 0. Domain still stays the same. All real numbers except your asymptote. Range, all real numbers except the other asymptote. Transformations. I still have a reflection over the x-axis. I still have a stretch of 4, but what's new on this one is I have a vertical shift, and it's going up 2. If it's in the denominator, it does the opposite of what you think. So if there was a minus 3 here, it would go to the right 3. If there were a plus something here, it would go left. After the fraction, addition goes up, subtraction makes us go down. Okay, graph. My normal points, again, over 1/2. We've got our reflection, so that's going to make us go down, and our stretch of 4 over 1, down 1 times 4, and over 2, down 1/2 times 4. Only difference is, well, 1, I didn't make that tall enough, but now instead of being at 0, 0 for my black hole, I'm at 0, 2. So I draw that in as an open circle with asymptotes going left and right and up and down. Those are harder to see. So when I start graphing, I start counting from this black hole. So I'm going to go right 1/2 and down 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go right 1 and down 4, and right 2 and down 2. Oh, good. 2, 0. That was my x intercept, so it's a good thing that that got graphed there. Otherwise, I would need to graph it. Okay, and then curve around. Remember, don't come up and touch your asymptote. And then we have these same points up here too. Left 1/2 and up 8. Okay. 2, 4, 6. It's going to be up clear up there. Right or left 1 and up 4, and left 2 and up 2. So remember, bring it down, get close to your asymptote, but do not touch or cross. Sorry, this is such a long video. This is a long review. Okay, 15. Next page, finally. Oh, okay. These graphs are their rational graphs. This is 8-3. Your 8-3 notes look like this, so you might want to grab them. On these ones, you've got to factor. You will need to find the discontinuities of holes and vertical asymptotes, domain, and then we need to use this chart for horizontal asymptotes and x-intercepts. And then I don't believe we were asked to find y-intercepts. So you might want to find these 8-3 notes to look back at. Okay, so 8-3, I have x squared minus x minus 2. Well, you will need to factor that by the AC method. X minus 2, x plus 1. And in the denominator, I have a GCF. Oh, interesting. In the denominator, I have a GCF of -2, which is going to give me x squared minus 4. But if I look at this x minus 4, or x squared minus 4, sorry, I see that it's difference of squares. So it's going to be x plus 2 and x minus 2. Okay, so the first thing it asks is for discontinuities. So those are your holes and your vertical asymptotes. Well, how you find a hole is you look and see if there's a common factor, numerator and denominator. Well, I see that I have both of those have an x minus 2. That tells me I'm going to have a hole with an x value, whatever that equals 0. So set x minus 2 equal to 0, add 2 to both sides, I'm going to have an x value of 2. Now to find the y value, you kind of have to think back to Algebra 1. So when you have an x value and you have an equation, so my equation now is x plus 1 divided by 2 times x plus 2. How I find the y value is I sub that in for x. So this will say 2 plus 1 divided by 2 times 2 plus 2. Okay, 2 plus 2 is 4. 4 times 2 is 8. So it's going to give me a denominator of 8, and 2 plus 1 is 3. Sorry, I did that in kind of a weird way, but you would get 3/8 if you simplified that. Okay, and timeout. This is a -2, so this would be a -3/8. And 3/8 is So this is going to be negative 0.375. It's just going to help me graph it. Okay, so after you find your hole, you need to find any vertical asymptotes. Hopefully, by now in Algebra 2, you remember that you cannot divide by 0. Let's rewrite this. X plus 1 divided by 2x plus 2. Okay, so that's what's left of my, actually I can't write it there, I won't have room to graph it. So write out what's left of your equation. So that's what we can look at. That's what it is now. Sorry, I'm trying to squish everything in here. Okay, so now hopefully you remember in Algebra 2 that you can't divide by 0. So vertical asymptotes come from any place left in the denominator that has a variable. The only place left is x plus 2, so I set that equal to 0. I would subtract 2 and get x cannot equal negative 2. Okay, horizontal asymptotes come from comparing the degree. Now, I like to use the degree of the original because before it's factored, it's easy to see. So it's a squared and a squared. Remember, the degree is the exponent of the largest exponent when you have a multiple. So the degrees are the same. So looking at my chart for horizontal asymptote, when the degrees are equal, I have a horizontal asymptote at leading coefficient divided by leading coefficient. So my leading coefficient of the numerator was 1, and my leading coefficient of the denominator was negative 2. So I have a horizontal asymptote at negative 1/2. And now I need my x-intercepts. Okay, x-intercepts we kind of have a cheat code on. Again, you know you can't divide by 0, but can you divide 0 by something? Yes. So wherever the numerator equals 0, that's your x-intercepts. So instead of putting 0 in here and multiplying, you can just set this x plus 1 equal to 0. So your x-intercept would happen at negative 1, 0. And now, okay, so I have my hole, my vertical asymptote, my horizontal asymptote. Okay, so I need domain. Domain is going to be all real numbers except any points of discontinuity. And remember, your discontinuity are your holes and your vertical asymptotes. So I'm going to have all real numbers except x equals, and it's only the x value of those 2 points. So except x equals 2 and negative 2. Oh, sorry, this is a point, this is a line. Okay, I think I'm finally ready to graph. So I'm going to draw this in, and I'm going to draw in my hole at positive 2, negative 3.75, so right about there. My vertical asymptote is going to be at negative 2. And my horizontal asymptote is going to be at 1/2, so just under that. Sorry, I made that hole a little bit big. Just under there. Okay, and then I need my x-intercept at negative 1, 0. And now I think I'm ready to graph. So grab our graphing calculator, and you're going to type in either your original function or what's left. Remember, put your numerator in parentheses, and when you hit your division sign, put your denominator in parentheses. And then I know you think we're going to do table or graph, but you're wrong. We are going to do second table, and this table is not set up right. Okay. Well, this table is set up to ask, so I am, oh, sorry, no, it's, I don't know what's going on with this table. There we go. Okay, sorry. My calculator was having some errors. Okay, so now we look at our graphing calculator, and then we graph those points. I don't know that I want to go clear out to negative 8, but I guess I don't have a choice. Because these are all really close, and I can't tell what's going on. Okay, so it looks like negative 8, I'm just under my asymptote, just under my asymptote, okay. And at negative 3, I go down to 1. So these are all getting really close to my asymptote. So what that is telling me is that I need to do some more investigating. Okay, let's look at this side then. I'm guessing this side is going to connect and then zoom down, but I need to double check. So on this side I have 0 is at negative 0.25, 1 is at negative 0.3, 2 it says error because I have a hole, and negative 2 it says error because I have a vertical asymptote. Okay, these are all just really close to here. Wait. Yeah, really getting close to my asymptote. Okay, so since my table wasn't really helpful, I can't tell what it's doing close to the asymptotes. I'm going to go second table set and make it ask me for the x value so I can choose some that are close. Okay, so I'd really like to know what it's doing at negative 1.5. Okay, at negative 1.5 it's at 0.5. So here that tells me I'm going to be up here. So what's it doing at negative 1.9? It's at 0.4, or it's at 4.5. So up here. So that tells me that this branch is zooming up, because remember it either zooms up or it zooms down when you get close to an asymptote. Now this branch I'm pretty sure is going to be zooming down, but I need to check. So at negative 2.1, so just after my asymptote, what's it doing really close here? It's at negative 5.5. So good. That tells me it's down here. 1, 2, 3, 4, 5.5 down here. So this one is zooming down. Okay, there we go. That one's graphed. 16. Another one. Okay, so I have to factor that, so it's going to be x plus 2 and x minus 1 divided by negative 3 and x plus 3. Alright, now hopefully we can do this one a little bit faster. Okay, so a whole, remember, occurs when you have a factor that cancels. I don't, so I will not have any holes. I don't know why I tried to put that in parentheses. Next, vertical asymptotes. Vertical asymptotes occur in the denominator, so x cannot equal negative 3. Horizontal asymptotes. Horizontal asymptotes, you remember you need to compare the degree. So my degree of the numerator was 2, and my degree of the denominator was just 1. So when the degree of the numerator is greater than the degree of the denominator, it says there will be no horizontal asymptotes, but there may be an oblique or a slant asymptote. So I don't have a horizontal asymptote. Okay, x-intercepts. On this one I'm actually going to have 2, because I have 2 things in the numerator. So negative 2, 0, and I'm going to have 1, 0. And then, what else? Domain. Domain, remember, skips your holes, so I don't have one, and your vertical asymptote. So all real numbers except x equals negative 3. And, let's see, is that it? Holes, vertical asymptotes, horizontal asymptotes, domain. Okay, well, ready to sketch already. Okay. Negative 3, there's my vertical asymptote. And no hole, x-intercept at negative 2 and at positive 1. Okay, so I am ready to type that in and look at my table. Okay, so I need to look at something that is to the left of my asymptote so I know what that branch looks like. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so at negative 8 I'm at 3.6. At negative 7, 3.3, 3.1, so at negative 5, 3, 4, 5, I'm at 3. Okay, so that's looking like that's probably an oblique asymptote. And then I'm at 3.3 again. So I'm going to second table set and change this to ask so I can see what it's doing really close. to there and make this negative 3.5. Yep, that's what I figured. 2, 3, 4, 2, 4.5. Okay. So this is coming in with a slant asymptote. You can kind of see how it's coming down like that right there, those points when I connect them. And then it's going up. So I need to make that kind of slanty. Because when we have no horizontal asymptotes, it says you can have an oblique asymptote, which is a slant one, which comes in here like that. Okay, change my table set back to ask. So we can do this side. Okay. At -1, I'm at 0.3. 0, I'm at 0.2. Oh, that looks weird. And now I've gone to negative numbers. Okay, so let's get one on here that I can actually graph. -3, I'm at -0.5. Okay. So now I need to go back to my table set and change it to ask so I can tell if this is zooming up or zooming down. So I need to put in a number that's really close to here, so -2.5. And when I put in -2.5, it says -1.16. So I would say that's zooming down. And then this, I'm guessing, is my slant asymptote, and it's going to be going down like that. Okay. And if you want to make a more precise graph, remember, just graph more points. 17, 18, 19, and 20. These are from 8.6. It looks like 17 and 18 are working together problems. So 1 plus me over 1 plus you equals, 1 over me plus 1 over you equals 1 over us. So on 17, it takes Natalie 8 hours, so 1 over 8 for Natalie, to clean an attic. It takes Jessica, her friend, 10 hours, so 1 over Jessica. How long would it take if they cleaned it together? So X is going to be time took to clean together. Okay, so now this is back to, like, I don't even remember what number at this point that we did earlier, but it is a radical equation. So we figure out the common denominator and multiply by all the pieces. And then we cross off what cancels. So the 8 cancels, this is going to be 10x. The 10 cancels, this is going to be 8x. The x cancels, this is going to be 80. So I have 18x equals 80. So x equals whatever that is. 4.44. Uh-oh, sorry.
Teachers, just a reminder that we'll be in the library at 7:25.
Okay. So it takes 4.44 hours to clean together. Sorry, my handwriting's messy. I have a meeting in 5 minutes. 18. Working alone. Norachi can sweep his porch in 8 minutes. One day his friend Danielle helped them, so that's going to be us, and it took them 5.22. So my x this time is going to be how long it took Danielle. So my common denominator here is 8x and 5.22. So 5.22x plus, oh my gosh, what is that? 8 times 5.22, 41.76. And then over here I have that canceling, so 8x. Alright, now I subtract 5.22 from 8x and I get 2.78. X, divide by 2.78, and I'm going to get 15.02. Okay, so this was in minutes, so it would take Danielle 15.02 minutes to sweep the porch by herself. Okay, 19, these are distance, rate, and time ones. So we set up our chart. We have with, on this one we have a river, so we have with the current, and we have against it. Remember, okay, so we have a distance. Cooper's boat is traveling 11 miles downstream, so that's with the current, and 8 miles upstream. The current is 2 miles an hour. Okay, so this is tricky. In rate, it always needs to be the thing that is moving in the current. So in this case, the boat. And the boat is what I don't know. So the boat speed is going to be x. So it always needs to be the thing that is moving, or the boat, then the current that is acting upon it. So with the river is going to be +2, against the river is going to be -2. Okay, now it says, it doesn't say, but I'm assuming that oh no, it does say, it says in the same time. So I know the time is going to be the same. So if I have distance equals rate times time, I can solve that for time by dividing by rate. So time equals distance divided by rate, so I can use my distance and my rate to set up a proportion. Oops, that's an 8. Okay, so I have 11 divided by x plus 2 equals 8 divided by x minus 2. So then I cross multiply. I've got 11x minus 22 equals 8x plus 16. I subtract, I get 3x equals, and add 38, so x equals 12.67. So the boat is moving at 12.67 miles per hour. Okay, last one, I'm going to squish it on here. Okay, this is an escalator. Yeah, an escalator. So same thing, distance, rate, and time when you're going with the escalator and when you're going against it. Okay, with the escalator, we are able to go 40 feet. Against it, 24. Our rate, how fast is the escalator? Okay, so again, we don't know how fast Johnny is walking, so Johnny's speed is x. So with the escalator, he's going to be moving an extra 4 feet. Against it, it's going to be taking 4 feet away from him. So 40 divided by x plus 4, and 24 divided by x minus 4. Set up that proportion because it says that it is equal time. That's how we know we can make those equal. Okay, so here we go. 40x minus 160 equals 24x plus 96. Subtract that over, I'm going to get 16x. Add that over, I'll get 256. So my x is 16, which tells me that Johnny is walking 16 feet per second. Okay, remember this is your Chapter 8 notes, so if you need any other review, check out your Chapter 8 notes.